Okay, assalamu alaikum my brothers and sisters. Let's come back. We are going to discuss chemistry of form 2 for your information. Here on board we have relative atomic mass and isotopes. By the end of this chapter, you must know the definition of relative atomic mass as well as isotopes. And by the way, you must know how to calculate, because this question, how to calculate RAM. Simply because this question, this kind of concept of chemistry is basically based on calculation, of which you're going to see. But before we proceed to that, we must know what relative atomic mass is. Okay, relative atomic mass is the average mass of an atom of the element compared to that of carbon 12. Don't forget, is the average mass of an atom of the element compared to that of carbon 12. Don't forget. So that is what we normally call relative atomic mass, which is abbreviated or contracted as RAM for your information. Then isotopes are atoms of the same elements that have the same atomic number, but different mass number due to the difference in the number of what? In the number of electrons. Due to the difference in the number of electrons. In the number of neutrons. So we can say isotopes are atoms of the same elements that have the same atomic number but different mass number due to the difference in the number of neutrons. So in the examination, if you don't tell us due to the difference in the number of neutrons, tell us why isotopes are called the same atomic number but different mass number. It's due to the difference in the number of what? Neutrons. So we are going to say isotopes are atoms of the same elements that have the same atomic number but different mass number due to the difference in the number of what? In the number of neutrons. Don't forget that RAM is mostly calculated as RAM is equal to percentage abundance times mass of the element divided by 100, because relative atomic mass is basically based on calculations of which you are going to see for your information. So we are saying RAM is gotten as percentage abundance of the element multiplied by of the atom multiplied by mass number of the element divided by 100. So we can say we can now look examples about this. Let's see the first example. Let's see the first example. Example 1. You are told, look at this example. You are told an element X comma consists of 3 isotopes. With mass number with the mass number of 22, 24 and 25 with the percentage abundance of 89.6%, 6.4%, 4.0% respectively. Okay? Respectively. What does it mean? Respectively. percentage is for the first one, understand? This one is for the second one, and the last one is for the last one there with a mass of 25. So you are told find the relative mass of the element, the relative atomic mass of element X. Find the relative atomic mass of the element X. Full stop. So we are going to solve it here, and let's try to solve it here, guys. You are told an element X consists of 3 isotopes with mass number of 22, 24, and 25, with a percentage abundance of 89.6%, 6.4%, 4% respectively. Find the relative atomic mass of element X. We know that solution to this problem. We know that RAM is equal to percentage abundance times what? Mass of the element divided by 100. So in this situation, we are going to say RAM is equal to, we have 22 times the first percentage, which is 89.6. Close the bracket, plus open the bracket. Look here, 24 times the second percentage, which is 6.4, plus open the bracket. 25 times 4.0, total divided by 100, because you have 3 isotopes. So RAM, therefore, RAM is equal to, then you must have what? Your calculator. This is our calculator. So we'll have, look at 89.6 times 22. It will give us 1971.2 plus 24 times 6.4. That will give me 153.6 plus 25 times 4, 100. Total divided by 100. So this will give me plus 100 plus 1971.2. That will give me 2224.8 divided by 100. So we are going to say mathematically 1, 2. So it will be 22.25. Okay? 22.25. 22.25. Okay, the RAM you are going to get must fall in between these three. Yes, within these three, it must be in between 22 and 25. So this is the final answer for your information. That will be our final answer, guys, for your information. And then we will see one more example so that you understand better this thing. Let us see one more example. Let's see example 2. Let us see example 2. Let us see example 2. Example 2. You are told our example 2 is saying chlorine 34, chlorine 35, chlorine 35 forms 75%. 75%. Look at this point. Of the total mass of chlorine, and chlorine forms 25%. Forms 25%. Full stop. You are told calculate the relative atomic mass. The relative atomic mass of chlorine. Period. Now, for us to get the relative atomic mass of chlorine, this is the solution. Okay? Let's go back and read the question first. Let us go back and what? And read the question first. You are told chlorine 35. That is what? Chlorine 35. That's the mass number of chlorine. Forms 75% of the total mass. So we're going to say RAM is equal to percentage abundance multiplied by mass of the element divided by 100. For your information, guys. Then here, you must write the formula in case it's your normal exam. Then we have two isotopes of chlorine here, chlorine 5 and chlorine 7. So we're going to say RAM in this situation is equal to 35 times 75, close the bracket, plus, again, that is 7 times 25, total divided by 100. So we'll have RAM is equal to, so 35 times 75 is how much? Let's get the calculator. 75 times 35, 2625, plus that is 7 times 25 again, 925, total divided by 100, plus 2625. So this will give me 3550 divided by 100. Mathematically cancel these two. Then you have 101. So this will give me that 5.5 as the final answer. So I'm going to say RAM therefore is equal to that 5.5. Can't you see now? It's falling in between what? 35 and that 7. Okay? So that is the final answer. So this is the forward way of solving questions that can come from relative atomic mass. But we have the reverse questions, okay? Questions that are what? The reverse questions of RAM, of which you're going to see them right now, okay? Let's see example 3, guys. Let's see example 3. Let us see example 3. Let's see example 3, guys. Let's see this one. But for you to solve this kind of question, you must be a mathematician, by the way, okay? And it's very important to learn mathematics. Okay? This is example 3, guys. Example 3, you're told lithium has 2 isotopes. Lithium has 2 isotopes with masses, with mass number, with mass number 6 and 7. Period. 6 and what? 7. Then full stop. You are told if the relative atomic mass, if the relative atomic mass of lithium is 6.94, comma, determine the percentage abundance of each isotope. Determine the percentage abundance of each isotope. Period. Okay? Let's come here for the solution part. You are told that lithium has two isotopes with a mass number of 6 and 7. Yeah, mass number 6 and 7, full stop. If the relative atomic mass of lithium is RAM is 6.94, determine the percentage abundance of each isotope. Okay, we are going to say let the two isotopes be X and Y. But what we know is that the fact that we know is that when the two percentage abundance are summed together, they will give us what? 100. So we are going to say, let the two percentage abundance, let the percentage abundance of the two isotopes, let the percentage abundance of the two isotopes be X and Y. Let the percentage abundance of the two isotopes be X and Y. Therefore, we can say X plus Y is equal to 100. This is equation 1. Because the percentage abundance of the first isotope plus the percentage abundance of the second isotope must give us what? 100. So we say let the percentage abundance of the two isotopes be X and Y. Okay? Be X and Y. So the summation will give us what? 100. Okay? Remember, we also have what? The relative atomic mass. We know that RAM is equal to percentage abundance times mass of the element divided by 100. So let's express that RAM. So RAM is equal to, I can say the first one is what? 6. So 6x, which is 6 times the mass of that element, plus 7y, 7 times its percentage, divided by 100 must give me what? 6.94, which is the RAM. So mathematically we eliminate this one, times 100, times also 100. So cancel these two. So we'll have 6x plus 7y is equal to 694. The decimal will go. This is what? Equation 2. This is equation 2. Okay? Then we can say now, solving the two equations simultaneously, we can say solving the two equations simultaneously. Let's solve them simultaneously, yeah? Okay? So when you want to solve these equations simultaneously, you can use what? Substitution method or what? Elimination method. So you can say we have x plus y is equal to 100. This is our equation 1. We also have 6x plus 7y is equal to 694. Okay? 694. So let me use, this is equation 2. So now let me use using elimination method. Using what? Elimination method. We can also use substitution. Remember, we have x plus y is equal to 100. Then we have 6x plus 7y is equal to 694. Then here, what we're going to do is, we will equalize the middle numbers. Here we have y and here we have 7y. So let's place here 7, here y. This is from one concept of mathematics. 7x plus 7y is equal to 700. Then it will be 6x plus 7y is equal to 694. Then same sign, subtract them. So this will be 6 is equal to, cancel these two, x. So that is what? The percentage appearance of the first one. But inform them, x plus y is equal to 100. So 6 plus y is equal to 100. Take this one to the other side. Y is equal to 100 minus 6. So y is equal to 94%. And this is 6%. So this is the first question of RAM for your information, guys. Okay, make sure you do a lot of research. Then in our next class, God willing, we'll go ahead and see our information. Okay, otherwise I wish you the best. Make sure you subscribe our YouTube channel and share with your friends.